So if I were splitting it up, I would have two groups, okay, high, low, 0.6. So by using the complement rule, we know this is 0.4. And then we break this up. This is the probability of accident given I was in the high risk group.
Oh, okay. Yeah.
This is probability, and instead of writing N, I would write either A with a line up here or C, sometimes a bar. I don't know what your class uses, but it's either this, or this, one of those for complement.
Okay.
So for now, I'll just put complement until you tell me that your class uses something else. Okay? And then this would be probability of accident given we're in the low risk group. And this would be probability of no accident or accident complement given that we're in the low risk group. Okay? And those were given as 0.01. This would be 0.99. And if this is 0.03, this would be 0.97. Okay?
Mm-hmm.
So that's the first thing you should have drawn when you saw this problem. Any questions on how I set that up and what those lines mean or anything? Accident given high risk group.
High risk. Yeah,
okay.
That's the conditional probability.
Okay. So then if you want, remember, if you want the intersection of A and B and you're given conditional probabilities, you can multiply the conditional times the condition to get the intersection. So if I want intersection of accident and high risk, I would multiply 0.03 times 0.4.
So,
okay. So for instance, accident, and let's do intersect with, what did I say, high risk or low risk? Doesn't matter. Let's do low risk. So if I'm doing that, that would be probability of accident given low risk times probability of low risk. So 0.6 times 0.01. You see how I did that?
Mm-hmm. Yeah. Probability of low risk. Okay, yeah, okay, yeah.
So now you could be asked something like this. You could be asked, if there was an accident, what's the probability he was in the high risk group? So how would we write that using conditional probabilities?
So, so that would be the probability that there was an accident given high risk.
We calculate exactly what we're looking for. Probability of high risk given accident is going to be equal to the intersection. There.
High risk.
If you don't understand what I'm doing, look up Bayes' rule. If you watch any of my videos, I've got several videos on all this stuff.
I know it.
Okay. Again, not the class you want to fall behind in. Okay, I'm just trying to give you a friendly warning.
Mm-hmm. Yeah.
I know you have other classes that are pretty heavy as well, so just, if anything, try to stay ahead in this class. All right, so the top is pretty straightforward because that's just going to be the intersection of these two events, which is the product of
high risk.
A given H.
Times.
Now the bottom part though is got two scenarios because we can have an accident if we are in the high risk group,
mm-hmm.
Or if we have accident in the low risk group.
So at the bottom we could just add them up, right?
Yep. And we're going to use the individual rule that I used up here to get their individual probabilities for intersection. Understand?
All right, let me digest this one. Going through it, like the process, the steps. So then the first thing we did was since we have two different groups, and it's like one or the other, we can break it up into the factor 3. So here we started.
In Bayes' rule, that denominator is the total probability. So you have to look at every scenario that accidents occur.
Where? At the very bottom?
Look at the screen where I'm writing.
Oh, I see. Total probability
of accidents. So either in the high risk group or low risk group. So because we said the word order, we have to add each one individually. And then how do we get these things? Well, we just use this multiplicative rule for conditional probabilities to find the intersection. I'm at A, B, take the conditional times the condition.